Hello everyone, a pleasure to be here today introducing Resistant AI from the Czech Republic. And let me just very quickly share the presentation. So everything in order? Okay, good. So as you can see on the screen, well, we call ourselves Adaptive Security for FinTech. And what actually means is that very practically, as part of the introduction, let me say we work with banks, we work with financial institutions such as insurance companies, lenders, buy now, pay laters, and all kinds of fintechs as well. And what we do, and the adaptive part, is the AI and machine learning in our system and in our technology. What it does is we basically provide automation, but we also protect automated processes in those companies. And the AI and the machine learning finds fraud in both documents, digital documents, and transactions. So let me give you first a quick overview of the history of the company, which is quite brief. We have a very technical based and experienced team with AI. They have 14 years of experience with artificial intelligence in network security and defense. And the previous company of this team and of the core of the team has been Cognitive Security, which was successfully acquired by Cisco in 2013. And they basically grew the Cisco threat analytics product from 0 to 25 million users as the team. And just in terms of the technical expertise, we've got 7 PhDs in AI on the team with hundreds of patents and papers in AI and security. And we are backed by some of our biggest investors in the world, including Index Ventures, Credo, and Seedcamp. So let me give you a bit of an overview of what we do first before I get into the details of the technology. And so on the document side, we deal with forgery detection. And so this is very practically in terms of lending, in terms of banks, where what they do now is they onboard the customers remotely, mostly. And so in order to verify the identity of the customers, in order to verify their income and their address, they use documents sent to them remotely in a digital form. So these could be PDF files or images or scans of pay slips, bank statements, any other KYC documents, IDs, and whatsoever. Well, in this case, nowadays it's very, very easy to forge and manipulate these kind of documents. So you can use any sort of editors and very simply create a fraud. And this fraud is not detectable by human eye. And also the verification of these documents is very time consuming as they process thousands and thousands of documents every day. So that's where the technology comes in. It automates the process and then finds any sort of manipulation, any sort of forgeries in those PDFs and documents. And I'll show you a bit later just how it looks. But for now, let's also talk about quickly the transaction side of our business, which is dealing with risk, fraud, and anti-money laundering. So in this case, it's about transactions, and obviously companies, again, financial services like buy now, pay later, or e-commerce platforms, which are booming at the moment. Well, they process thousands and thousands of transactions, again, every day. And it's very difficult to make sense of them in terms of anti-money laundering and in terms of finding fraud. And so what the AI and the machine learning that we developed does is that it basically assesses and verifies every transaction within the entire context of all the transactions that were made. And it finds patterns, it finds the signs of fraud and connections within these transactions. And that way it's able to spot fraud, it's able to reduce false positives as well, which are very key in terms of making the business more efficient, but I'll again touch on that later. So in terms of the documents, and because this is a FinTech and AI-based conference, obviously it'd be nice to get into the details a little bit. So let me just quickly show you what it does. So basically with this AI machine learning technology, every single document that's being processed by the lender or by the bank is automatically within seconds processed, and there was a trusted verdict given to the document. So very easily you can see whether the document is trusted or normal, whether there's a warning, or whether it is high risk. Trusted means that this document can be actually automatically processed without any human contact whatsoever, because the AI didn't find any modifications within the document, and the machine learning identify this as a model of a document that we see on a regular basis, that they can say this is trusted, you don't have to look at it. Normal verdict, that means no evidence of any modification, but again, it's not a common document, so maybe look into it. Warning, that means there are signs of modifications, but it doesn't have to necessarily mean fraud. Whereas high risk, we say that the document is most likely fraudulent because of all the signs of tampering and modifications we see. And very quickly, let me show you what it actually looks like. So this is on the right side, the picture is what you see as a fraud specialist when you open this particular file. You receive a bank statement and it shows you a high risk. So, well, we don't believe in AI and machine learning telling you one thing and don't provide the evidence for it. So that's why we show you basically everything, the whole story. On the right side, you can see this is the actual original document from NatWest Bank. But when you click on the show in document, basically it highlights you all the changes, all the forgeries, all the modifications that were made by the fraudster. And on the left side, you can see the whole story being painted for you as a picture, where you see the PDF was modified, see exactly where, how it was edited, what editor it was used with or edited with, and that it contains both fonts from Windows and Mac OS, and several details like that that show you that, okay, this is probably very likely a fraud, and it helps the analysts a ton, and also helps to focus on these particular key documents rather than wasting time on perfectly legit ones that can be automated. And in terms of the documents, not only that we are able to find any fraud and forgeries, we can also very reliably extract automatically different kinds of content from these documents. This is typical for bank statements in PDF form or ID cards of any kind. And basically, we are able to, well, the customer is able to choose what details they want to automatically process and extract from the document. So typically that's names, any sort of numbers like the ID number, or any sort of numbers like the final number in a bank statement. So this also helps with the automation of the entire process very much as a part of the whole automation of the scoring process. Well, now let me go to the transactions. And as I said, this is basically in businesses like buy now, pay later, e-commerce platforms who offer loans or payments that are being paid later. And what the system here does, again, is just protecting the system and improving the automation. And so here on the scheme, you can see that basically we can put the system in front of the protected system of the customer. And that way, the AI and the machine learning identifies, it basically goes through every single transaction within seconds or within milliseconds rather, and identifies and links fraudsters together, because there are some fake identities, there are account takeovers, and there are multiple types of manipulation. The AI machine learning identifies patterns and basically filters those fraudsters, and it can prevent it. The model oversight, that means it's we put it after the protected system, and here we can reduce significantly the false positives, and we can find additional attacks later after the protected system did its work, but we can still find them later and protect them. So there are two protective layers that are protecting the system. As an example, basically as a very practical example of these kinds of fraud, one that is very common is account takeover. What it means, and it's shown here, is that there is a customer in buy now, pay later or e-commerce platform that pays and the account is legit, everything works out, but then something changes, it gets taken over by a fraudster, and that means that it's unpaid and there's fraud. So we at the AI and the machine learning takes care and basically identifies so many different elements, like the identity changes, like the device changes, like the address changes, and it finds out that basically this is where the fraud happened. The delivery address changed. The person is no longer the person that was the legit one making the transactions, and they did a fraudulent attempt, and they bought something completely different and they didn't pay for it, and then it was rejected. The very next payment was rejected because the customer and the fraudster was found. And a very similar but slightly different use case, but also one of the most common ones, is generated or fake identities. And here in this case, basically the fraudsters target these platforms, target these buy now, pay later providers. And basically what they do is they generate completely different identities. They switch their names, they switch their addresses, they switch what they can to basically fool the automated system and to get away with fraud. So what we do is the AI and machine learning, again, analyzes so many different verticals or so many different variants, like the geography, the location, the device, the identity, and what they buy. And so here again, this is an actual fraud use case where the fraudster kept changing the identities, but he would still never get away because he was found based on the location, based on the device that he was using, and based on the, let's say, a pattern in the transactions. And again, it was basically found every single time. This is the same attacker, this is the same person, even though they claim they are someone else. One last thing that I will mention in terms of the transaction, and I think I mentioned that, was a reduction of false positives. And this is particularly used for anti-money laundering, for AML systems, and is also used for risk scoring for buy now, pay laters and online lending and platforms as well. And that means that basically the usual systems, they have a lot of false positives. So the fraud basically analysts and the AML analysts are bombarded by thousands upon thousands of false positive alerts. And here the AI and machine learning again can basically use the location analysis and all sorts of context similarities. And just on the left side, very practical example. So there was a huge spike of transactions for flowers, and it seems like there's probably some sort of fraud. But because the analysis found out that that was across the entire country, and then there are no similarities in context, we found out, oh wait, actually it's people buying flowers for Valentine's Day. So actually, in terms of transactions, seems like a fraud, but it's actually not. Whereas the second case, it's in basically a online food store, and again, slightly lesser spike in transactions, but because it was located in a very specific location and there were so many similarities in the context, the system automatically was actually able to spot one attacker that was doing everything. So, in terms of the results that basically the technology provides for these banks, for these online lenders, and for these buy now, pay laters, you can see here on the screen very simply, the system and the automation alone is able to prevent 50% of all the fraud incidents just by itself, and actually also find 15% of previously unknown fraud. And in terms of the volume reduction of the false alerts, it's able to reduce 85% of the alerts, which means 85% reduction in work for these operational teams. So very, very useful in terms of boosting the efficiency and automation in terms of finding fraud. So I hope I didn't take too much time. Very quickly, this has been resistant AI. Again, protection and automation in financial services, banking, and FinTech. We'll be very happy to meet any potential partners in Japan. It was a pleasure to be here, and thank you so much for your time.
I will be talking about the Wultra company, but I will also talk about, let's say, more content-driven topic of the important pillars of mobile banking or mobile fintech security. So we are Wultra, and we are, again, a cybersecurity company from Prague. We basically help banks and fintech companies. It's our narrow specialty, and we try to be basically the full scope service provider for digital banking and finance in terms of security. We have some main competencies. One of them is authentication, where we focus on cryptography and basically regulatory requirements for authentication in digital banking and finance. We have a very high focus on mobile security, which is the topic that I will talk about today in a little bit more detail. And we also focus on digital identity, because as the world is moving toward digital, of course, the identities also need to move in the digital world. In the Czech Republic and Central Europe, we cooperate with some of the largest brands. For example, with Raiffeisen Bank, we have a very good cooperation with the Czech National Bank, where we actually help with the area of PSD2 legislation. We also work with fintech companies. So we are able to work with small and big customers. So even if somebody starts small now and then they grow big, we are able to scale up with them and cooperate in long term. So what we noticed when talking to these customers is that basically everything ends up in the mobile phone these days. If you talk about fintech or digital banking, it's not only mobile first, it's mobile only. Even in areas that were traditionally a little bit more conservative, such as Europe, it's currently approximately 50% of users who use mobile banking at least once a week. Of course, in Asia, this number will be significantly higher. The users are actually using mobile banking more often. They initiated 26% more mobile banking session in 2020 when you compare it over 2019. These are global numbers. And they not only use the mobile banking more frequently, they actually spend much more time in the payment applications. On the other hand, people who use mobile banking name security as the second biggest concern. And the people who do not use mobile banking do not do so for mostly the security concerns. So it's the first main reason not to use mobile banking and mobile finance applications. So how do we fix that? We can clearly see the big picture. The mobile usage is growing and security concerns are clearly there. So we need to build secure mobile applications. What we can see is that it's a complex topic. You need to have multi-layered protection. And we currently have three main pillars. Of course, in practical deployments, we have approximately 20 more types of security elements that we embed, but these are the main topics. The first one is cryptographic protection, which basically protects transactions and login. Then it's active in-app protection, which prevents impacts of routing, mobile malware, etc. And the last one is mobile intelligence, which mainly gives visibility to the issue of mobile security, but it can also help identifying some new types of threats and stop them as they happen. So I will go over these three topics in a little bit more detail. So let's start with cryptographic protection. That's actually my personal specialty, because when I talk about Wultra, I view it as a Swiss watch factory, basically a Swiss watch manufacturer. Cryptography is a very precise field, something that is very delicate and can break up very quickly. So where does cryptography enter this mobile application? So the mobile application always needs to communicate with some backend services, with the systems of the bank or fintech company. And when transferring data, you need to assure confidentiality of account and transaction data, and also integrity and authenticity of, let's say, access or approval of operations such as payments. And these algorithms are, or these use cases are usually backed by some cryptographic algorithms. But what history teaches us is that cryptography is actually always evolving. This is something called Caesar cipher. It's a very simple, primitive cipher that is basically just a rotational shift of the text. And at the time, when people didn't know how to read, it was actually a very efficient type of cipher. But from today's perspective, when you compare it to today's cryptographic algorithms, it's almost ridiculous. But as it turns out, even today's cryptographic algorithms, such as RSA or elliptic cryptography, which are currently taken for granted, are also starting to look a little bit ridiculous, specifically because of quantum computers and increasing computational power of such machines built on completely new principles. So the main troublemaker was Mr. Shor, who actually showed up with this Shor's algorithm that solves a very difficult problem very quickly on quantum computers. And as a result, it breaks RSA or elliptic curve cryptography. So luckily, there are some new pieces of mathematics, some new cryptographic algorithms that are very advanced based on mathematics of lattices or supersingular isogenies that can withstand the quantum computers. It's not like a quantum computer is some magical device sent from heavens to break everything very quickly. It's actually just a new computational paradigm, just as Caesar cipher was one day a very strong algorithm, and now we have RSA and elliptic curves. These new mathematical systems are ready for the future. So what we can do, we can actually help you make your application quantum resistant. We have some own implementation of algorithms that are actually linked from a NIST quantum resistant challenge that actually we embedded into our cryptographic system for authentication, and you can use them right now. So the second topic that I want to mention is active in-app protection. So what is the point of doing cryptography in a mobile app if the mobile application itself is not secure, it's not in a trusted environment? So just if you look at mobile malware, it's actually skyrocketed in 2020, according to research by Kaspersky. And it's not just about mobile malware, it's about mobile threats in general, impact of rooted devices, or even this global topic around companies like Huawei that are discussed. That's always something that raises concerns. And according to Gartner, by 2022, which is sooner than we expect, it's next year, at least 50% of successful attacks against clickjacking and mobile apps could have been prevented if these applications used some sort of in-app protection. It's not just because of Gartner that we should do this. It's also about this general methodology called OWASP. Mobile applications basically need to be secured. And this is where our mobile app shielding comes in. Mobile app shielding is actually protection of your application from the inside out. You can put our plugin into the mobile application, and we will do the integrity checking for you. We will protect you from malware. We can protect the runtime impacts of breaking and rooting of devices. We can make the application difficult to study for the attacker by advanced obfuscation. We have features that protect personal data, for example, from leakage through screen readers, and so on and so on. It's basically a module that helps us to make the application secure, including the cryptography. It's just a nice side effect. So, but how do you know that these things are even happening, right? Is anybody actually attacking your application? Is there any issue that you should be solving? So this is actually where we go to the third topic, which is mobile threat intelligence. Mobile threat intelligence basically mainly gives you visibility into the problem. And we have a product called Malverlytics, you can look it up, which basically collects data from the mobile application about cybersecurity incidents. Because of this collection, we are actually able to double check the data against our own AI-powered technologies, but we can also double check them with companies that are far ahead, such as existing antivirus maker companies or independent researchers in databases like Kudos. And if we find any discrepancy or any issue, anything that is unexpected, we actually notify multiple systems. One of them is our own security operations center that we automatically include in the service, where we evaluate the situation and we help to investigate the incident. Then we are able to send the data to any security operations center that you are using. We have an example of Elasticsearch, which is a very simple type of let's say database for big data, but it's a good or well-known system. And of course, we are able to contact the bank directly through API or webhooks. So that's Malverlytics. And we provide this beautiful to look at console where you can actually see all the threats and all the issues that we identify. So suddenly you are not in the blind. You can see the attacks happening. You can gain the visibility that you maybe didn't have before. So we will show you the threats. So these were the three main pillars of mobile FinTech application cybersecurity, cryptographic protection is probably where you would start, because it's the basic protection that usually has some legislation requirements behind it. Then the active enough protection to make the application itself secure, including the cryptographic protection. And then to see what is happening, you need a mobile threat intelligence system, which essentially gives you the visibility and allows you to communicate with other systems in the FinTech application to stop the fraudulent transaction, for example, that was mentioned earlier here. So, of course, we do not have too much time to go into detail in a technical part, but we are actually a very well-known company for being very open. One of the best decisions that we made in the very beginning is that we decided to publish our cryptographic systems as open source solution. So you can visit our developer portal, where we actually have some nice tutorials, some nice overviews of the solutions, and we even have some contact information right there for a real-time chat, where you can contact us and immediately get a response from our engineers or business representatives regarding the solutions. We will be happy to advise you or to show you how the solutions works to conduct POCs. This is also a very good proposition, not only for FinTech companies, but also for the vendors, for companies that are building systems for FinTech, because we cooperate very often with solution partners. We only seldom work directly with FinTechs. So I would like to encourage you and welcome you to look at our developer portal. And this was basically everything for me for the introduction. I would like to thank you for your attention. And of course, we would like to stay in touch with you. So if you are interested in having the conversation with us, please connect with me on LinkedIn. I would be happy to join your network and discuss possible cooperation. Thank you very much.
Hello, everyone. I'll be as brief as possible, and thank you, Petr and Jiří, for your presentations. I will basically complement what you just said. ThreatMark as a company is a security company. It leverages AI and machine learning, and I will explain how and why. And our motto is that we're bringing trust to the digital world. So what we do is basically an anti-fraud suite. We focus exclusively on the banking sector, while expanding our activities to also to FinTech companies and FinTech market, like e-wallets and payment gateways and so on. And what we bring on this market is a holistic approach to an online banking security. So I've done my research and checked the situation in Japan. So the amount of money that's been lost through damages caused by online banking fraud, you can see here from 2013 to 2020, which seems like it's quite interesting that these numbers are jumping up and down, maybe because of the fraudster developing new techniques that are being mitigated and fought by companies like ourselves. So what are the typical scenarios that we're helping to mitigate or to fight is the account takeover, it's phishing, which is voice phishing, remote access Trojan, and stolen credentials, for example. So there's a lot of money that's being stolen from the bank still, and especially by means of the online ways or world. So what we do is that we protect the digital banking channels, both on the, let's say, the computer or online and on the mobile. So as we imagine a person that's approaching his or her bank account to perform, for example, a transaction or check account balance, there are certain steps. So usually the person will access the bank's website, and they will log in. They will navigate through the application, and then they will perform transaction or do whatever they want. And within each of these steps, there's a many things that can happen, and also the fraudster that can steal the credentials and so on can, let's say, fake the identity of the legitimate user and try to steal his or her money. So as we take a look on these, let's say, 4 steps, we have the first one is at the access, where definitely a couple things needs to be checked from the bank side. If it's a legitimate user accessing from his or her device, if the connection is okay, if the person is not coming from a Tor browser, anonymous proxy, and so on, if the browser is not infected, and so on, if there's some kind of a malware, or the person is a victim of a phishing attack. And last but not least, the device fingerprint is a quite valuable source of information, whether we are or the bank is dealing with the legitimate user or not. Then when logging in, definitely what needs to be checked is the location, as resistant AI were presenting. It's a typical, whether is it a typical time. We also work quite heavily with the logon biometrics to, let's say, identify the legitimate user or distinguish between the legitimate user and the attacker or fraudster. And then there's a navigation. So we're asking, like, is it a typical clickstream? You know, is it a typical behavior of the user within his online banking environment? And through all of these steps, we're continuously checking his identity, his behavior, and we're looking for any sign of threats that might be endangering the user's account. And the last step is obviously the transaction, when we need to look for some anomalies and to see if there might be some, for example, anomalous amount of money sent. And all these things combined will provide a complete picture of what's going on and whether the user is legitimate or it's a fraudster. So we are basically answering the basic questions like, is it your device that you are using for, you know, or to approach your bank? Is it a secure environment? Is it infected? Is it not infected? Are you accessing from a safe browser and so on? Then is it really you, based on the biometrics, based on the contextual information? And with all of these information, we can then compare the information that we have about the bank's user, about you, performing, for example, the transaction and doing some actions with your profile. And if there's a match, there's no problem, and you can seamlessly go through all of these steps, and you won't recognize anything. So the last, for example, the payment I mentioned, so you can see, and you can seamlessly send the money further. So, for example, if you're sending typically small amounts of money and suddenly there's some big amount of money, we combine all of these information that we are continuously collecting through the whole session to provide a final score that will tell the bank whether there should be some next step or some step up in the terms of authentication or some security process, or it should be cleared as a regular payment from a legitimate user. That's okay. So when there's a low risk throughout the whole journey, everything's processed and you won't recognize anything because you are a trusted user and this is trusted payment. So how we do it, we actually collect a lot of information about the user's behavior and we create a profile of this user based on his behavior, based on his device, location, and many data points that then we can compare this profile with this actual session that's happening in the real time to provide the scoring for the bank to be able to react on that. So this is what actually the bank usually sees, only the payment that some money was sent from your bank account to some other bank account, which can, in case of, for example, you're buying a new car or you're paying some, I don't know, like buying maybe a yacht or something. So it can be a lot of money that will just randomly appear, and they will see, okay, there's a huge amount of money. We should take a look on that, and it can create a lot of false positives to base your fraud investigation based just on the amount of money. While ThreatMark provides a lot of contextual information, as I mentioned before, is about the device, about the behavior of the user, and about the session, where we can check all of those, and it will result in a lower score because even the amount of money that's being transferred is high. Everything else is okay from the perspective of the context of the session, user, device, and so on. So I would just briefly describe some main use cases. It's an online fraud prevention solution So from the beginning until the transaction, we're continuously evaluating the user identity, and we can detect way more fraud than a traditional fraud detection solution based only on transactions. Also, what our customers like is that there's a, let's say, seamless experience that we provide to user by somehow invisible second factor authentication. So the user is not bothered by any push notification or SMS code in 90% of the cases when the risk score is low. So some banks can even save a lot of money on these services. And what is the most important, it provides a seamless user experience for the bank's client. And last but not least, as my colleagues previously mentioned, the reduction of false positives, because we collect and provide a lot of information to the bank, so they don't need to investigate something that doesn't need to be investigated. And how it works, we basically deploy our so-called probes on the internet banking side, and also we have a mobile SDK, and then we connect with the bank's environment. There are some data collected on the server, and we provide the analytical tools to that. And as Petr mentioned, we also have a very nice console to look at and easy to work with for investigating the fraud. What is also an added value, we have a SOC department that's monitoring all the threats 24/7. So even something that's not being properly catched by our automated tools, we can analyze manually within this department. The solution can be easily set up in a couple of days. Well, more realistic in a couple of weeks, depends on the bank's processes. But we can protect from let's say from the very beginning, we can collect information and protect the client. So it's not a complicated process, and we can set it up both in the bank's environment, on premises, or in the cloud. And just some information about our company. Obviously, we are Czechs, founded in 2015. Now the solution is being distributed in over 4 continents. The company is around 65 people now. We've been growing quite rapidly, around 70 to 100% a year. And we are now covering more than 25 million banking clients, mostly in the Central Eastern Europe, but we have clients in Canada, UK, Africa, and all over the world. And what is also important is that Gartner listed us as one of the important online fraud prevention vendors in the 2020 market guide. And I would just mention a couple of references here. We also cooperate with the technology companies like HID, CGI, NTT, and others to provide the best experience to our customers. And this is like we provided by integrated solution. And as you can see, we are working also with the major large European banking groups. I would mention maybe on the first place Erste Group, which is distributed in over 8 countries, where we cover more than 8 million banking clients. So for those that are familiar with the solution in this or solutions in this area, this is where we position ThreatMark among other solutions. So we have traditional fraud detection systems like FICO, SAS, FIDSI, and so on. And these are usually based on the transaction, and they use strong analytical tools. Then there is an area of authentication and behavioral biometrics, where companies like Behaviosec, Biotech, and more are present, and as well as threat detection solutions like ThreatMetrix, IBM Trusty, or F5. So basically, to explain it somehow simply, we are combining the strengths of these solutions into one product suite that's able to cover the whole customer journey. So just to summarize, we are there from the very beginning, checking your environment, your device, your laptop, your browser, for any signs of a malware, any signs of a threat. Then we check on the logon with behavioral biometrics if your identity if it's really you and not someone else typing in the credentials and so on. Then we see how you navigate through your online banking application, and we look at the things you do and compare it with your profile. And then we also take a look on the transaction and what's happening there when you are sending money out of your bank account. If everything is okay, and for example, you haven't changed your location in 3 minutes for about 5,000 kilometers. So, and on top of that, there's a strong analytical platform or engine where we continuously work with the collected data to provide better and better solution to our clients. It's divided into 3 modules, which is something I think I don't need to bother you with right now. So it's a modular solution, and most of the banks are combining these modules, for example, with their existing solutions for transaction fraud detection. So thank you very much for your patience and attendance on this webinar. And if you're interested in knowing more, just feel free to reach out to me directly, or you can also reach out to our partner in Japan, the company Information Security Incorporated. So thank you once again, and I wish you a great rest of the evening. Thank you.